web, if you didn't know this, the web has become the largest infection vector for malware, with email slightly behind it. And there are a number of ways that malware can infect a user's computer from the web. There are drive-by downloads, websites that the user just happens to click on, or even possibly not even clicking on, the browser happens to hit, and it automatically exploits and installs malware into the browser or on your machine. There are tons of fake security software sites, antivirus 2008, antivirus 2009. If you've never looked at it, check out the malware database. If you Google it, you'll find it. The guy who runs it, Lithium, he maintains a huge list of illicit security software on the web where it actually gets installed. It's actually malware. It's going to install more malware onto your system and just really screw it up. And finally, there are attack toolkits out there specifically made to infect your system. They're very well made. They're web-based. They will launch multiple attacks against a browser. They'll actually determine what operating system, what browser, and plugins that the person hitting the site have installed, and customize the exploits based off of that, just so they can get their malware on your system. So, and these are only 3 of the possible ways. Google has a great paper out called "The Ghost in the Browser," which goes into a lot of detail on how the browser can be exploited to install malware. Now, as investigators or analysts or security people working in corporations or whatever organization you're in, eventually you're going to come across the problem where web-based malware has gotten onto a system under your control. Unfortunately, the trend has been that antivirus is going to be of little help. There is a definite period of time between when a piece of malware is released and when it's reliably detected by antivirus. And unfortunately, that time period appears to be growing. So in my research, there's at least 3 to 7 days of time lapse between when a piece of malware is released on the web and starts infecting systems to when your antivirus provider is going to detect that. And even when it detects it, there's no guarantee that your antivirus is going to completely remove it or remove the other things that that piece of malware had already downloaded and installed onto that PC. Because of this, manual analysis of the malware may be required. You may need to actually go in and see what the malware does, what files it drops, what registry entries it hits, and so on, in order to determine how to get it off your system. And of course, since this is an investigation, you don't know what the malware is doing. Time is of the essence. You need to get in there and be able to figure out what's going on very, very quickly. Now, like I said, malware analysis has a number of problems on its own. The malware could be packed, which makes it more difficult to analyze. It could have anti-debugging or anti-virtual machine or anti-analysis capabilities built into it so that when you start using your tools to analyze this malware, it just automatically shuts down or does something completely benign. Web-based malware has a number of its own problems. The first is many of the exploits that actually infect your machine and tell where the malware is downloaded from are often hidden with obfuscated JavaScript. This isn't always the easiest thing to decode. There are some tools, some great tools out there like Caffeine Monkey and Malzilla, which will help you in de-obfuscating the JavaScript so you can see what's going on. The problem, though, is attackers realize this, and so they're starting to create obfuscated JavaScript, which is browser dependent. And what I mean by that is they're using JavaScript code and using mathematical algorithms within that JavaScript, which have different results based on whether you're using Internet Explorer or Firefox. And since Caffeine Monkey and Malzilla are based off of SpiderMonkey, which is the JavaScript engine for Firefox, if the obfuscated JavaScript is using a mathematical algorithm, which only Internet Explorer will resolve correctly, your obfuscated JavaScript you may not be able to figure out what your obfuscated JavaScript is doing. So you may run into a problem with that. Malware authors, or the bad guys putting up the malware on the web, are smart. They know that we as analysts are going out and downloading their malware to analyze it. Therefore, they're creating what I'm terming as one-shot infections, meaning you have one chance to go and get that malware off that website. And any subsequent attempt to grab that malware off the website results in a redirect to a benign page or just a 404 page that doesn't show you where the malware is. So you have one shot in order to grab that malware to analyze it. If you miss that shot or you screw it up, you're screwed. And they're doing this a number of ways. They're doing it via firewall-based capabilities where they see an IP address come in and they just blacklist it after the first attempt. They're doing it cookie-based, which you can get around, but they're getting pretty smart at this. They're having browser header requirements when you go to get the malware. So if you don't have a specific user agent or referrer in your browser header when you go to get the malware, you're going to be redirected to a benign site. It may have browser or plugin dependencies. So if you're not running Flash or you're not running some Adobe plugin or plugin X, or you're not running IE or Opera or the specific browser it's looking for, it's not going to serve you up the malware. And again, you don't know how far down the rabbit hole this malware infection goes. I've seen many sites where you go to one site and there's an iframe pointing to a second site, and on that second site there's another iframe pointing to a third site and to a fourth site, and then finally on the fifth site is where you get the infection. So just by hitting the first site, you may not be getting the actual infection, or you may not be able to find the malware. You have to go down 5 or 6 sites in order to figure out where that malware actually is. So with all these problems, we need a solution which is going to automatically analyze the malware in its natural environment being the browser. We need to somehow create an environment that we control for malware analysis that's going to use the browser to go out to this infection site or whatever infection site we find to automatically download the browser as a normal user would. Well, SandNets are an excellent resource or an excellent tool for doing this. SandNets are essentially a virtual network for running programs safely. If you know what a sandbox is a single program or container or system which is used to execute programs in a safe environment. Sandbox IE is a great example of this. It encapsulates Internet Explorer, whatever program you want, into its own virtual container, and nothing can get out. Well, SandNets expand this a little bit. They take it one step further where you have two systems, two components, where you have the sandbox being the system that we're going to run the malicious code on, and then a network simulator. And I'll talk a little bit more about the network simulator, but essentially what it does is it emulates the internet, or whatever network you want. If you want to go to a website, it's going to say, I'm that website. If you want to go to an IRC server, it's going to say, I'm that IRC server, and act like that, and then respond back and pretend to be whatever you want it to be. In a true SandNet, there is no contact with the outside world. It is totally segmented from any other network. There are two types of SandNets. You can go physical, where you actually have two physical machines, which are acting as the sandbox and the network simulator. Or you can go virtual, where you're using a virtual machine to act as the sandbox and the network simulator as all in one encompassing machine. Or let's say two VMware sessions, which act as the sandbox and the network simulator. And there are disadvantages and advantages to both. The great thing about SandNets is it allows you to automate the malware analysis process. You control this environment. You control everything within it. And so you can automate it going out to wherever you want it to go, starting up whatever programs you want to start up, accessing whatever malware you want it to access. By automating the environment, you not only speed things up and allow you to analyze malware much faster, you always have the same results. You have a reliable and consistent process which always happens, which helps keep your results consistent. If you want to fool around with SandNets, there's a great open source SandNet out there called Truman. It was written by Joe Stewart of SecureWorks. If you Google Truman, or actually if you look in the notes of my presentation, which will be online at Owasp and at my company site, corelogic.com, I have all the links in there. But Truman is a great open source SandNet to get you started. Joe Stewart released it, I think maybe 4 or 5 years ago. He has not updated it since, and he has said that he's not updating it. So it's really great base framework for you to start working on. That's a 3 or 4 minute overview of SandNets. If you go to my company's website, corelogic.com, I have a much longer presentation which goes over lots of aspects of SandNets. So if you're curious about that, please contact me, or I can get you that presentation somehow. Now, this is just a graphical representation of what a SandNet truly is. you've got your virtual network here. Or I'm sorry, this is the entire SAN net right here, completely segmented from your internet or internal network. There's no way for you to get from one to the other. Within your SAN net, you've got the sandbox and the virtual network, the network simulator. And these are usually two machines which are connected via a crossover cable or a hub or something like that so they can communicate with each other. Now, simulating the network services on the network simulator portion of the SAN net can be done a couple of ways, but the most common way is to have scripts or programs which run as network services on that machine. Like I said, the network simulator, it's the part of the SAN net which is going to respond to the sandbox. Whenever the malware on the sandbox sends out a network request for whatever protocol it wants, DNS, IRC, SMB, FTP, whatever you have, it's going to respond and act like that service so you can record what it does and how it interacts with services. It essentially is fooling malware to thinking it's online, and if implemented properly, it does a very good job of doing this. To give you an example, we've got our sandbox here and our network simulator, and they're connected via a crossover cable. We run some malware on our sandbox, and it sends out a DNS request for irc.bot.tld. The network simulator is going to intercept that, and it's going to respond with a DNS response saying that irc.bot.tld is at 192.168.10.87, a different IP address than what its actual IP address is. So, the malware gets this DNS response and says, all right, I want to connect to an IRC server on port 6667 on IRC, the IP address that the network simulator sent back to us. Well, the network simulator is going to intercept that request via firewalls. Typically it's done with IP tables, is how Truman does it with IP tables redirects. And it's going to act as that IRC server. It's typically what you have is an actual IRC server or Perl script or whatever other scripting language you want, which is going to send the IRC responses back to the malware, and then the malware is going to pretend to log it, or is going to log into a channel, wait for commands or what have you, and you're going to be recording all of this information. So now you know what server it's trying to go to, what IRC channel it's trying to get into, any passwords it's trying to use for that IRC channel, and so on. So you can take that information and do research with it on the web, send it off to law enforcement, send it off to the IRC operators, or whatever you want to do with it. But you did all of this without it going to the web, without it going to the internet. Right. Yes?
Have you seen attempts with malware to use static IPs rather than making?
Yes, the question was, have I seen attempts for malware to use static IPs as opposed to DNS? I have seen it. It's not done as common because with a static IP, if that gets shut down, the malware is SOL. However, with the way that the IP tables redirects are set up, it will still intercept that address and it will still respond to that address and pretend that it's that static IP address. Any other questions? All right. Now, if you look at what a SAN net is, where it's totally segmented from any other network, that poses a problem for us. Because what we're trying to do here is give our SAN net a URL to go to get infected. If we don't allow outside access within our SAN net, that's a problem, because how are we going to go out and get that infection and just follow that infection to wherever it leads? I mean, yes, we could, step by step go and use wget to go out to the first URL it tries to hit, and then analyze that and then go to the second URL it tries to hit. But we run back into those problems of obfuscated JavaScript, the one-time hits, the browser dependencies, and so on, which are really causing our problems and are slowing down our analysis. So the solution is to use a hybrid approach. What we're going to do is we're going to take the analysis capabilities of our SAN net and then the control capabilities of a honeynet, put them together so we have our SAN net analyzing the malware, and then our honeynet control capabilities, a firewall, monitoring the network traffic going out to the web and then controlling it to be whatever we want. Essentially, we're just taking our SAN net and we're modifying the network traffic to allow it to go outside to the internet, to whatever sites it wants to go to. So as we go to our infection site, it's actually going to that site and it's actually grabbing that malware and continuing to do whatever it wants. Now, there are problems with this. I mean, we don't want our SAN net to get infected and then start attacking other machines. That's why we implement the data control capabilities of the HoneyNet into our hybrid SANnet. And I highly suggest going out to the HoneyNet Project's website and checking out their Gen 2 HoneyNet papers, because they do an excellent job with talking about the different ways to perform data control on network traffic going out to prevent it from attacking other systems. Well, to summarize, there are a couple ways you can do this. First, you can only allow certain ports outbound. So since we're analyzing malware, let's say I only allow port 80 and port 443 out. Well, the disadvantage to that is, well, what happens if my malware tries to connect to a web server or an IRC port on some non-standard port? It's not going to be able to go out because I'm blocking that. So that's not a great solution. The second one is to actually allow everything to go out but throttle it. Say we only want to let 20 packets per hour to go out, so that if it starts trying to scan other machines or perform exploits on other servers or send out spam, we're going to stop it after the first 20 or 30 packets. This does put your SANnet a little bit at risk of attacking other systems, but it really limits that risk as to what it can do. And usually, by throttling it, you're still going to be able to get the malware that you want and the infection that you want on your system. Finally, you can actually use a network intrusion prevention system like Snort, Snort's inline capabilities, to watch the network traffic and prevent additional attacks. So that if Snort sees an attack going out, it'll just drop the packet and not let it go out. There's a little bit of a problem with this, because if you do that, you could actually prevent your SANnet from getting infected, which is what you're trying to accomplish. And usually most SANnets, when they implement this to go the hybrid approach to allow it to go out, they use a combination of the three. Now, in order to analyze web-based malware, we created an internal hybrid SANnet. We use it for malware analysis and software testing, and we found it particularly effective for analyzing web-based malware. The way we have our SANnet set up is it's based off of Truman, the open source SANnet, but we extended it using WebJob and custom coding. If you don't know what WebJob is, it's an open source project which allows you to schedule and execute requests through a web server, through CGI scripts on a web server, with authentication and encryption all built in. We use this so that we can set up our malware, have it do whatever we want, and control exactly what it does. Our SANnet reloads very, very quickly. We can get about 5 to 7. It takes about 5 to 7 minutes per malware, and then we're reset and we're able to analyze another sample of malware. It all depends on what options we set up and what we want it to do, and everything's customizable. And we've implemented a large number of configuration options within our SANnet. We allow full internet access using the throttling method to allow it to go outbound. I think we've set it up so that after 20 or 30 packets, it just starts dropping everything else. Now, within the SANnet, there are 3 types of monitoring that we do. We do in-band monitoring, out-of-band, and network. For the in-band monitoring, these are tools that are running while in the victim OS, in the SANnet, while the malware is running. And with these tools, we're able to look at what the malware is doing, see what system APIs it's calling, seeing what files it's dropping and registry entries it's hitting, and so on, while the malware actually does its thing. The problem with in-band monitoring tools is that if the malware drops a rootkit, the rootkit could start hiding data from your malware. If the rootkit is set up to hide a file from being seen, your in-band monitoring tools are probably not going to see that file, and that could skew your results or mess up what you're trying to accomplish, seeing exactly what the malware does. To give you some example of some in-band monitoring tools, Process Monitor from sysinternals is an excellent one. There are tools like InControl5 or RegShot, which will take a snapshot of your system before and after the malware runs, so you can see what changes happen to the system. Fport is a great tool for seeing what service is talking or what program is talking on what, or listening on what port, and so on. So those run while in the sandbox while the malware is running. Then there are out-of-band tools. Now these tools examine the sandbox or the victim computer when the OS is shut down. So essentially what happens is we're going to take our SandNet, we're going to boot it up into Windows, install the malware, and then shut it down. And then from another system or another partition, we're going to examine that victim computer to see what happened. The advantage to this is you can see what happened to the system without worrying about a rootkit. The rootkit is no longer running because you're in a different operating system or you're analyzing the disk like you would in a forensic examination. In this capability, you can examine the files and the MAC times on the files without worrying about a rootkit hiding it. You can examine the registry and see what's in the registry without worrying about your rootkit. Now, the disadvantage to the out-of-band tools is you don't get the information that you would typically see in a live response forensic analysis. You're not seeing what processes are running. You're not seeing what network connections are out there. You're not seeing files which the malware created and used temporarily and then deleted, which is why we use both in-band and out-of-band tools. And finally, there's network monitoring. Essentially what we have going on here is on our network simulator, we have TCP dump running, and it's recording all network traffic and saving it as a PCAP data. From that PCAP file, you can do any number of things. You can do traffic analysis. If it's downloading files, you can extract the files from that PCAP data, and so on. So you have a complete record of what the malware was doing. Now, of course, the disadvantage to this is if you're not actually, since we're sitting on another machine and just watching the traffic go by, if the malware starts using any encryption through SSL or SSH or any proprietary encryption algorithms that it has, you're not going to see what's in that until you actually break open the malware, figure out what it's doing, and crack that encryption. And then second, for the network, we're actually logging all of our faux services that we're running. The IRC server that we're pretending to be, or the IRC server that, actually that's wrong, I'm sorry. It would be in a normal SandNet. With the network, within the PCAP data, you actually are logging all the clear text protocols that you're seeing. Normally in a SandNet, you would be logging all of the faux services that you were running, but since in this instance, since we're going outbound and we're allowing it to interact with whatever is on the internet, we're just going to be recording that in the PCAP data. Now, automation. Again, automation of a SandNet, or in this case our hybrid SandNet, is going to provide us speedy results, which gives us what we want. We want to analyze and figure out what's going on in a very, very fast process. And then it'll also give us consistent and reliable results. So every time we run a piece of malware, it's going to run the same tools. It's going to run it in the same way, so that we know that we didn't mess up our process in any way, and we forgot to run a tool or we forgot to perform an action, which is going to give us our desired results. Now, the way we do this in our internal SandNet, and what I've seen most SandNets do, is they have a master script that's used to control the functionality of the tools or your process. The script is going to start the tools, process monitor, TCP dump, whatever you want to start up to monitor your system, and it's going to open Internet Explorer or your web browser to the infection site. I found that not a lot of people know this, but Internet Explorer, if you run iExplore and then the website you want to go to, it's going to automatically open up and go to that website. So there's a little bit of command line foo going on here with Internet Explorer to allow us to get to where we want to go. After that, the script kind of sleeps for a little bit, maybe 2 or 3 minutes, lets the infection happen, and then it wakes up. It's going to stop the tools, save the data, and then reboot the machine so we can do our out-of-band analysis. Now, scripts are great, and I'm a Unix guy, so I love command line tools. Unfortunately, in the Windows world, where 90% of the malware is, there are a lot of GUI tools, and GUI tools don't always have a command line equivalent, or if they do have a command line equivalent, it's not always very powerful. I've seen a lot of really great tools. Process Monitor, I think, is a good example of this, where you can do hundreds of things within the graphical user interface, but at the command line, you can do maybe 2 or 3 of those things. So the problem we have is how do we automate these GUI tools? And another problem is, well, we want all of this malware to install automatically. You know, what happens if the malware pops up a EULA, or it pops up an OK button for you to click on? We're trying to get this to be totally automated, so we don't have to do anything on our own. We just, you know, submit the malware, sit back for a couple minutes, grab a cup of coffee, and come back, and there are our results. So we need some way to automate all of these GUI functions. Well, there is a great scripting language out there called AutoIt. And essentially what AutoIt is, if you remember BASIC, it's a basic type language that's used to automate anything you can do in the Windows GUI. If you want to simulate a mouse click, it'll do that. If you want to simulate, you know, the mouse moving or closing down a window or anything like that, AutoIt will let you do that. So what we can do then is take AutoIt and write a number of scripts to perform our analysis, to open up, let's say, Process Monitor, set up the options within Process Monitor in the GUI that we want to happen, and then, you know, shut it down after a certain amount of time. All automated within the GUI, nothing command line driven. Or we could write a monitor script within AutoIt so that it kind of sits in the background, and if it sees a window pop up with an OK button, it'll automatically click on that OK button. If it sees something that looks like a EULA, it's going to hit the accept button. Or if it starts to go through like a generic install process, which a lot of the fake security software will actually do, it'll click the next button or the finish button for you. So everything is going to be automated as much as possible. And I'm actually going to show an example of this in a couple minutes. All right, so that's kind of an example of how we did how you can set up a hybrid SANnet. I talked about before the presentation that I have on SANnets. It goes into much more detail on how we set up ours internally to perform malware analysis. But I'm actually going to show you an example here of how it can work. Before I go, are there any questions? Yes.
Yeah, I have a question. So you were talking about like infection using the web-based behavior, users
Right.
using the browser and getting infected. So my understanding is most of the infections won't happen because you are running an unpatched version of browser versus you have unpatched plugins and right? And
Yes.
that's kind of the vector which malware will use to look at your browser and your JavaScript will look at it.
Right.
So how do you simulate those behavior? Like, okay, for this malware may not get infected because you're not running a particular plugin or a particular unpatched version of the browser. How do you do that?
Well, the question was, how do we simulate certain plugins within the browser which are going to allow an infection to occur? The answer is we don't simulate it. We actually have the way our SANnet is set up, and a way I've seen other SANnets do it is we have a number of different images on our system which are loaded with certain versions of IE or certain plugins. So let's say we have an image which is running IE7 and some old version of Flash and some old version of Adobe. I'm not picking on Flash or Adobe, I'm just, you know, using them as examples. We'll use that image to go to that website. So the actual plugins and the actual vulnerable browsers are in there. We don't update them, they're static images. So we do run into a problem every once in a while where an exploit will want a particularly old version that we don't have loaded up, or a newer version that we don't have loaded up. So when that happens, we either have to create, usually what we have to do is create a new image that will contain that exploitable plugin. The key to this is we're not using virtual systems at all or simulating anything. These are the actual physical systems which are getting exploited. The reason we went away, or we decided purposely not to use virtual systems for our sandbox or for IE, is because more and more malware, it's very common within malware now to have anti-virtual machine detection in there. And if it sees that anti-virtual machine technology running, or VMware or Sandbox IE, or there's even some for the popular SANnet, the free SANnets out there like CW Sandbox or Norman Sandbox, Threat Expert, if it sees those things on the system, it'll automatically shut down and delete itself, or in some cases, you know, I haven't seen personally, but I've heard in some cases where it actually wipe out your machine because it knows that you're an analyst and you're trying to figure out what's going on with your machine. Not to get too far into our architecture and how we do this, but we've set it up in a way where our images, we don't need to reload Windows, and we don't need to reload IE for every single image we want. We have a system called DDP. DDP is an open source tool that we created, which lets you take basically a byte, a diff between two Unix DD images. So what'll happen is we'll take our original image with Internet Explorer, let's say 5. We'll load IE6 into it, shut it down, and then take a binary diff between the two images. And then we just save that binary diff. So whenever we want to, let's say now, load up IE6, we apply our original image, we apply the diff, and then we boot up the system. And it actually occurs very, very quickly. It's much faster than you would think. So that's essentially how we do it. Yes?
For example, the recent JavaScript malware that comes with the massive injection.
Yes.
A lot of it is made in China and attacks in China, and they're targeting just like the talk that I heard downstairs from Java server, which is what we've seen. A lot of times it's attacking very specific plugins that are only available in Asia.
Okay.
For example, in China, they don't use MSN or Skype. They use QQ.
Mm-hmm.
QQ as a manual plugin.
Right.
And also attacking plugins to a lot of online games and things like that. So, what do you go about detecting these different plugins that are not that commonly used in the US? And the second question is, a lot of these malwares starting January this year, they're detecting your IP.
Right.
So for example, if you're launching two sets of environments, okay, let's say one with Firefox and one with IE, they're only serving the exploit once for each IP. So they log your IP, and the next time they're not going to serve it. And they're, aside from detecting different sandboxing techniques so that they know whether they're being executed inside a sandbox or not, what they're also doing is very primitive detection. For example, if I don't detect any mouse moves or keyboard clicks, I'm probably inside a sandbox, and I'm not going to do anything.
Mm-hmm.
Or I'm just going to delay, after I exploit your IE, I'm going to delay 2 hours without doing anything.
Mm-hmm.
So if your sandbox runs for 10 minutes, you're probably not going to.
All right. To answer your first question, which was, how do we detect when it wants to use a plugin which is not installed by default or not common in the U.S.? Well, within our SANnet, we actually have a video capture program running. So when it goes, actually, when Internet Explorer goes out to the website, we're going to see that a little pop-up comes up says you need this plugin, and then we'd actually have to go back and install that plugin, another image, and install that plugin. Now, like you said, with the one-shot infections, if it was a one-shot infection, at that point when we go back to it, we may be screwed because we can't get back to that. However, we've set it up. We have capabilities within our SANnet to use Tor and Provoxy to go out and go through these anonymity networks or whatever you want to term them to grab the malware. We don't usually use that because we don't want to abuse Tor for this, and we don't want to. It's much slower going through Tor usually. So we try to go going direct as much as possible. To answer your next question, which was remind me.
Primitive detection.
Oh, the detection of the mouse clicks and that. AutoIt, since it's simulating the mouse clicks and the keystrokes on the system, it can usually get around that. Not always, though, and in those cases where we may not be able to fully analyze it. I don't want to say that using a hybrid SANnet to analyze malware is a foolproof technique. There are flaws with it, but using the tools with AutoIt to simulate the mouse clicks and the keystrokes, we can usually get around that. Using Tor when we need it to go out to hit the web, the infection site from a different location on the web will usually get us around the one-shot infections and so on. Your last question on
That was
oh, okay. All right. So, all right. Did I kind of answer that for you?
have you had problems because we've noticed that recently there's been gateways that okay, that detects these kind of malware traffic or showcode traffic, and it just blocks the traffic. So the malware, the malicious JavaScript succeeds in attacking only if you load it in China. So you can't load it outside of China because you're blocked by it. So we can't, we don't see it actually.
Right. Yeah.
Unless we have nodes in China.
Right. Yeah. And see, that's how we would have to get around it. We'd have to the way we build our internal SAN, and I don't want this to sound like a vendor spiel because we don't sell our SAN nets. It's just totally internal. It's scalable, so we've actually deployed a number of different SAN nets around the United States. Specifically for this, so that we can go from different locations. We'd actually have to deploy a SAN net to China or Russia or wherever. And actually, we're doing that. We're internally we're working with some security partners who have offices in Russia and in London and a couple other international places for us to put SAN nets so that we can specifically do that. All right. So now I'm going to go into a case study of how a hybrid SAN net can be used. Now, as the little guy up there is saying, this section does contain URLs which will attempt to infect you if you go to it. These URLs are still active, to my knowledge, because I pulled them 2 days ago. So, if you go to these URLs, be very careful. You've been warned. All right, so we get a report of a malicious site, www.nmz.dp.ua. If you go to the site, the index looks like this. This is a very good example of obfuscated JavaScript. If you were an analyst and you wanted to figure out what was going on, you would actually have to go in and try to manually decode this or use Malzilla or Caffeine Monkey or any other custom JavaScript deobfuscation tools you have. Well, we didn't want to do this. We need to figure out what's going on with the malware on the site, so we put it into our SAN net and let it run to see what happens. Hopefully this will work. There we go. All right, this is a movie of what's actually happening within the SAN net. Here you see InControl5, which is a tool used to take a snapshot before and a snapshot after of the system, so you can determine what's running or what has been installed in that system. This is being run by excuse me. This is being controlled by AutoIt, our GUI scripting language. You didn't see the initial part because I've actually reduced. This is actually a 5 to 7 minute video that I've kind of time-lapsed to 2 minutes. So you're not going to see everything, but this is going to give you a pretty good idea of what's going on. I realize it's a little blurry, and I apologize. So InControl has started up. If you see at the bottom, it's kind of hard to see. Process Monitor has started up. And now we're launching our malware. We tell Internet Explorer to go to the infection site in question, and it's running. It's hard to see at the bottom where the little URL strings are, but it was hitting a number of other websites and getting infected. Internet Explorer pops up the privacy box, and this is something else that you could script within your GUI, within AutoIt, to automatically click OK. If you were noticing, there was a quick copying window as the malware was copying another file, and then boom, we get a EULA agreement for antivirus XP 2008. If you don't know, this is not actually antivirus. This is malware itself that will tell you that you're infected with probably 50 different types of malware, and it will try to get you to pay for that process or that piece of malware. Again, I've extremely time-lapsed this, but Process Monitor has started up in the background. We're starting to shut it down. And I think this may have actually been where I stopped the movie. If we kept looking farther, oh no, it's still going. Process Monitor is going to shut down in a second, then InControl5 is going to come back up, and we're going to take our second snapshot, save the results, and then shut down the system. Here you can see the pop-ups are coming up for Process Monitor. Again, all of this is being controlled by AutoIt. It's an excellent tool, and it's very, very powerful. You can do a lot with it. I didn't have it scripted to click agree on the EULA to move forward, but that's something that we're implementing in. In Control 5 is shutting down. As you see, the malware actually crashed Internet Explorer. And you can't see this, and unfortunately I wasn't able to take a movie of this, but within the network capture, in the background that we're running on our firewall, which is allowing the packets to go out, the machine started sending out hundreds and hundreds of network connections to web servers and SMTP servers. And we'll see what that was for in a second. And actually, at this point, the machine shut down, and if you would have, I didn't get a screenshot of it, but the background, the wallpaper of the machine was actually changed to a different wallpaper saying you are infected. I only have a couple minutes, so I'm going to go through this quickly. What did it do? It added over 70 files, 45 executable files, 1 driver, which is probably a rootkit, and 26 DLLs, at least 4 browser helper objects that I saw, 6 auto start entries within the registry in a number of different places. It added 3 services. It locked down the system. It turned off, its disabled task manager, and did another number of other things. And then in less than 3 minutes, it made over 1,500 SMTP connections to various places. Well, what was that about? It was sending out French spam. And if you would actually go to this website, which I did, and analyze what was going on, those websites were serving up malware as well. And this was a great example of not just one site was where the infection was taking place. When we go to that, if you went to that initial website, that obfuscated JavaScript was just an iframe to another site, which went to another site, which went to a 4th site, which actually had the malware on it. So, in conclusion, web-based malware isn't going away. Infections are going to occur, and we as analysts and investigators and security people need to figure out a way to quickly analyze them so that we can determine how to remove it. Hybrid SAN nets are excellent for this. We take a SAN net, the capabilities of a SAN net for analyzing malware, and the data control for of a honey net, merge them together, and then we have analysis that can occur in the browser's natural environment. It's automated, it's fast, and it gives you the results that you need. Thank you. Are there any questions? Yes.
Your DNS services.
Yes.
In the beginning, when you're first beginning your thing about the deployment or starting up, how are you going to know what he's going to resolve? What URL, not URL, what FQDNs you need to serve up without actually hooking one side up to the internet?
We don't actually use a DNS server itself. We have a Perl script listening on port 53 within the actual SAN net.
Okay.
Now, within the hybrid SAN net, it's actually going out to the actual DNS servers and resolving them that way. So we don't have to worry about that. Any other questions? Yes?
According to your experience, is it low interactive?
Yes. No, I would consider it a higher interactive SAN net because we're actually using the actual machines, but it's low interactive in the aspect that we're not doing anything. It's totally automated. I think.
So it's more like the send us the honey net.
Yes. Yeah. Here's my contact information.